9702 October November 2015. Paper 2 Unit 1 question number 5. This question is about the phase difference in stationary waves uh, and the properties of stationary waves. A progressive wave transfers energy, whereas the stationary waves does not transfer energy. State two other differences between the progressive wave and stationary wave. So, one difference is regarding the amplitude. All the particles will have the same amplitude in progressive waves, but in stationary waves, every particles will not have the same amplitude. Like at antinode, the maximum displacement is there. At node, zero displacement is there. So every particle does not have the same amplitude. Point number two, we know the phase angle of every particle. Let's say if I draw, this is the small picture, like the particle is moving. So every point, the phase angle is different, 0, 90, 180, 360. But whereas in a stationary wave, all the particles right between the nodes are in phase, right? They are same moving in the same way, but the particles adjacent to the nodes having the out of phase, they have the phase angles are different. Stationary waves are formed on a stretched string between the two fixed points A and B. The variation of the displacement y particles of the string with distance x along the string for the wave at time t is equal to 0 is shown, right? The wave has a period of 20 milliseconds and a wavelength of 1.2 meter. The maximum amplitude of the particles means that antinodes it's 5 millimeter. So that means when the period is 20 millisecond and the wavelength is 1.2 meters, so the half of the lambda will be zero point 0.6 and half of it will be zero point 0.3. Period, half of it will be the 10 millisecond and the half of the half is 5 millisecond. So if the question says draw a sketch, represent the position at the string at 5 milliseconds. So this is the position of the particle at 5 milliseconds. So and we construct the table according the graph accordingly. Like here it will be 1.2 seconds, so half of it will be zero point 0.6, right? So this will be as in accordance with the wavelength, right? Because it's a displacement distance graph. But on the same graph, if you want to plot the distance time graph, so here at 1.2 meter, it will be 20 milliseconds. Half of it will be 10 milliseconds, and half of it will be 5 milliseconds, right? And in terms of angular, we could see, right? It's here it's 90, it is 180, here it is 360, right? And we mark and check the another point. State the phase difference between the two particles of the string at x equals 4 meter and by point 4 meter and zero point 0.8 meter, right? So if we check from the graph, we marked here it's zero point 0.4 and here it's zero point 0.8, and it is the adjacent particles of a node right here. So that means the phase difference will be uh, out of phase, and if we check with the phase difference formula, the phase difference and the number of the nodes here is m, which is 1. So it is either we says 180 degree or pi radian. State and explain the change in the kinetic energy of a particle at an antinode between t equals 0 and t equals 5 milliseconds. A numerical value is not required. So at t equals to 0, speed is maximum, so the kinetic energy is very maximum. But at 5 milliseconds, where the particles are at, where the antinode is formed, particle will have the maximum displacement and zero velocity. And whenever zero velocity is, there will be no kinetic energy. So therefore, the kinetic energy is reduced to zero from the maximum.